Let's start by removing the update method, as we won't be using it in this lesson. So up here you have your MyPlane sprite from the previous lesson. Now we're going to give this sprite a physics body. So just add myPlane.physicsBody is equal to a skPhysicsBody object, and we can make this a square or a circle or a custom shape. I'm just going to use a circle. Using circles and rectangles are generally the best way to conserve computations by the physics engine per frame. So if I build and run this application now, it's gone. This is because by default the physics body's gravity is true. The standard gravity is meant to simulate something similar to Earth. So the plane has fallen off the screen down the bottom. I can now say physics body affected by gravity equal to false, and then it will no longer fall off the screen. Now it's a little bit difficult to visualize what's happening with the physics body. Luckily though, for iOS, there is some built-in functionality which helps you with this as of iOS 8. If you come back into your game view controller, you can add show physics and make it equal to true. And there's my physics body. Now for some reason it's way bigger than the ship. So we'll have to have a look now to see why that is happening. And silly me, I've put in the size of the scene, not the size of the plane. So I'll just change this now to be myPlane.size.width divided by 2, because it is radius, not diameter. And there you have it. The circle is now the same size as the width of my ship. Okay, so now I'm just going to add another ship to the screen, so enemy plane. They'll be equal to a SK sprite node, the same as our other plane. Its position will be in the center on the x-axis, but at the bottom of the screen on the y-axis. Its physics body will be the same size, and it will not be affected by gravity. Okay, so there's our plane. If I change affected by gravity to true on our plane at the top of the screen, you'll notice as it falls, it pushes the other plane off the screen. So firstly, when the plane touches the other one, there is a collision. Now both of these planes have mass. Just because one is not affected by gravity doesn't mean it can't be pushed by another object which is affected by gravity. So that's just handy to note. Okay, so what if I want more control about which objects collide with other objects? This is done with a collision bit mask. In this example I'm just going to use numbers, but there is a more robust way of handling it that we'll use in a later lesson. The collision bit mask refers to physics bodies that are affected by this physics body. So how do you say that your physics body is the same number as another one? Well, you do that with category bit mask. So if one sprite has a category bit mask of 5, then the only objects that will collide with it are the ones with a collision bit mask of 5. Okay, so now that I've set these up with opposite collision bit masks and category bit masks, when I build and run the application, you will now notice that the objects collide with each other in a much more static way. Neither of these physics bodies will pass the other physics body. What if you don't want the objects to collide? What if instead you want to trigger another function or do something else when these physics bodies touch each other or when they separate from each other? This can be done with a contact test bit mask. So I've added a contact test bit mask here. So when it contacts with another node with a category bit mask of 1, it will do something, but we have to tell it what it can do. If I build and run now, nothing's going to be different. The top node just falls past the bottom node and nothing happens. So what we have to actually do is tell this class that it is a delegate for the skPhysicsContact. Now we can do that by coming up here, putting comma, skphysics contact delegate. Then down in your did move to view, we just have to tell the physics world that the contact delegate is this class. So whenever a contact starts and ends, this delegate will try and call a function. So if you come down here, these functions are called did begin contact and did end contact. So in did begin, I'm just going to do a print line statement just saying contact. Now when I build and run the application, you'll see when the physics body passes the other one, it comes up saying contact. Okay, so one other thing to note about the physics world is you can change the gravity of it. And this will be a CG vector. So in its X and Y scales, you can just put in a number which will reflect the power of the gravity or the G-force in a particular direction. So if we change the gravity in the Y axis to -0.1, then it will go a lot slower. That makes that contact really stand out as well if you just notice that. And you can play with the gravity however you want and make it go in all sorts of directions. You can even change it to 0, 0 and have no gravity at all. Okay, and that's SK Physics in a nutshell.